For thousands of years, humanity has looked upward at the night sky. The stars guided our ancestors across oceans, inspired myths, and shaped our sense of place in the universe. To the ancient Egyptians, the heavens were the realm of gods. The Greeks saw constellations as stories written in the firmament. Polynesian navigators used the stars to cross vast oceans long before compasses existed. For all of human history, the sky was a canvas of wonder and mystery. Then, in the 20th century, humanity took its first real steps beyond Earth. The launch of Sputnik in 1957 was the spark that ignited the space age. Just 12 years later, the world watched in awe as Neil Armstrong set foot on the moon, declaring, "That's one small step for man, one giant leap for mankind." From the Apollo missions to the International Space Station, each milestone represented more than technological progress. It was a profound statement of what humanity could achieve when it dared to dream. But now, we stand at the threshold of a new era. The future of space travel is no longer only about exploration, it is about survival, economy, and destiny itself. The story of modern spaceflight began with fragile machines of metal and fire. Early rocketry pioneers like Konstantin Tsiolkovsky imagined using rockets to reach orbit as early as the 19th century. His equations laid the mathematical foundation for space travel, though he would never see a rocket fly. In the mid-20th century, engineers like Wernher von Braun and Sergei Korolev turned theory into reality. The space race between the United States and the Soviet Union accelerated progress at a breathtaking pace. Rockets like the R-7, Atlas, and eventually the mighty Saturn V became our ladders to the stars. These were not just machines, they were monuments to human ambition. Yet for decades, spaceflight was rare and costly. Each launch consumed billions of dollars, and every rocket was discarded after a single flight, as though every airplane were destroyed after its first journey. This inefficiency slowed progress, making space a domain reserved only for superpowers. Today, a revolution is underway. Reusable rockets are transforming space travel in the same way the steam engine transformed transportation. Companies like SpaceX and Blue Origin are redefining what is possible. The Falcon 9, with its booster that lands gracefully back on Earth, has slashed launch costs and increased frequency. Blue Origin's New Shepard has carried tourists to the edge of space, while SpaceX's upcoming Starship promises to carry over 100 people at once. Think of the shift. In the 1960s, launching one astronaut into space was a national triumph. Today, civilians, scientists, and even filmmakers are preparing for journeys beyond Earth. Space is no longer reserved for governments. It is becoming an industry, dynamic, competitive, and global. This democratization of spaceflight may prove as significant as the invention of the airplane. Just as the Wright brothers could not have imagined the vast air networks of today, our generation may be unable to fully grasp how routine and transformative space travel could become. Our closest neighbor, the Moon, is humanity's next great frontier. Unlike the fleeting visits of the Apollo era, today's vision is about permanence. The Artemis Program aims not merely to plant flags, but to build bases. Lunar settlements will test the technologies of survival, radiation shielding, closed-loop life support, and sustainable energy. Astronauts will learn to live off the land, extracting water ice hidden in shadowed craters. This ice is more than a resource for drinking and breathing. It can be split into hydrogen and oxygen, forming the basis for rocket fuel. Imagine the Moon as a cosmic gas station, a hub where spacecraft refuel before venturing deeper into the solar system. Its low gravity makes launches easier, turning the Moon into a gateway to Mars and beyond. Beyond survival, the Moon offers scientific treasures. Its untouched surface preserves records of the early solar system. Telescopes built on its far side, shielded from Earth's radio noise, could peer deeper into the cosmos than ever before. In many ways, the Moon is not just a destination, It is a stepping stone, a classroom where humanity learns how to live among the stars. If the moon is our training ground, Mars is our destiny. The red planet has captured human imagination for centuries. Ancient astronomers marveled at its blood-red hue. Science fiction writers turned it into a canvas for alien civilizations. Today, it is the focus of humanity's boldest dreams. Mars is harsh and unforgiving. Its thin atmosphere cannot shield us from radiation. Its temperatures plunge far below freezing. Dust storms can engulf the planet for weeks. Yet Mars is also tantalizingly Earth-like. It has mountains taller than Everest, canyons deeper than the Grand Canyon, and evidence of ancient rivers and lakes. It has seasons, sunsets, and a day only 40 minutes longer than Earth's. Colonizing Mars will require reinvention of nearly every human system: agriculture, medicine, architecture, psychology, and governance. Greenhouses will need to recycle every drop of water. Power systems must endure months-long dust storms. Communities will have to adapt to extreme isolation, building a society that is self-sustaining without Earth's constant support. Some envision cities under glass domes, glowing in the red twilight. Others imagine underground habitats shielded by Martian soil. The first settlers may face hardships greater than any explorers in history, but if they succeed, their descendants may call Mars home. And why go? The reasons are many. Some see Mars as a backup planet, an insurance policy for humanity's survival. Others see it as a challenge that defines our spirit, to test the limits of what we can achieve. For many, it is simply the next chapter in our endless desire to explore. Whatever the reason, Mars represents not just another world, it represents the future of humanity itself. Chemical rockets brought us to the moon. But if humanity is to explore the solar system and beyond, we must look to new forms of propulsion. Nuclear thermal propulsion could cut travel time to Mars from 9 months to 4 or 5, reducing risks for astronauts. Ion thrusters, already used by spacecraft like NASA's Dawn mission, provide constant acceleration over years, allowing probes to reach distant worlds. Solar sails, giant sheets that catch sunlight, could carry spacecraft without fuel, gliding across the solar system like ancient ships crossing the sea. Fusion drives, though still experimental, could one day provide immense power, turning interplanetary journeys into routine trips. And on the edge of imagination lies the warp drive, a technology that bends space-time itself. Though still theoretical, it reminds us that today's science fiction may be tomorrow's engineering. Each breakthrough in propulsion technology is not just a technical step forward, it is an expansion of our horizon. As space becomes more accessible, it also becomes more commercial. The opportunities are vast. Space tourism. Companies plan orbital hotels where civilians can float in zero gravity, gazing at the Earth from above. Asteroid mining, rich in platinum, gold, and rare earth elements, asteroids may one day be the mines of the future, fueling industries on Earth. Orbital manufacturing. In zero gravity, materials like fiber optics or alloys can be made with unmatched purity, revolutionizing technology. Solar power satellites. Massive panels in orbit could beam clean energy back to Earth, offering a solution to our planet's energy crisis. But with opportunity comes responsibility. Who owns space? Who regulates resources? The Outer Space Treaty declares space the province of all humankind, but as companies and nations stake their claims, conflicts are inevitable. The future of space will be shaped not only by technology, but by politics, law, and ethics. Even as we expand into our solar system, we gaze further, toward distant stars. Modern telescopes have discovered thousands of exoplanets, some in the habitable zone where liquid water might exist. The James Webb Space Telescope now studies their atmospheres, searching for signs of life. Projects like Breakthrough Starship imagine tiny probes, pushed by powerful lasers, racing to Alpha Centauri within a human lifetime. These missions are the first steps toward interstellar exploration. And one day, perhaps centuries from now, crewed ships may sail across the void, carrying human civilization to new star systems. To find a true Earth twin, a blue planet orbiting a distant sun, would not only answer the question of whether we are alone, but also offer humanity a second home. The future of space travel is more than science and engineering, it is a philosophical turning point. For the first time, humanity faces the possibility of not being bound to Earth. This raises profound questions. If humans settle other planets, will we remain one species or diverge into many? How will our cultures evolve in different worlds, under different skies? What responsibilities do we carry as the first intelligent species we know of capable of spreading across the stars? Some argue that space is humanity's destiny, that to remain on one planet is to risk extinction. Others see it as an act of hubris, expanding outward before we solve problems at home. Perhaps the truth is both, that in striving to reach the stars, we also gain the perspective to care more deeply for Earth.